What is the multiverse, and is there any evidence it really exists? The multiverse is a theory of physics and astronomy idea that says there are more worlds than the one we can see. According to this theory, each world in the multiverse might have its physical factors, natural rules, and even dimensions. The concept comes from several physics theories such as string theory, quantum mechanics, and cosmic inflation. Although the idea of the multiverse is still very academic and speculative, there are a few things to keep in mind when talking about the proof of its existence. Some of the most substantial proof of the multiverse theory comes from studying inflationary astronomy. According to the inflationary model, the early universe was thought to have grown very quickly and exponentially in the moments after the Big Bang. Multiple bubble worlds, each with its own physical rules and traits, could have formed during the inflationary time. Illusionary cosmology explains the multiverse theoretically, but there still needs to be clear proof of these other worlds' reality. String theory is an approach to understanding the fundamental forces of nature by speaking of elementary particles as tiny strings that vibrate. Different types of string theory have logical answers suggesting more than 4 space-time dimensions. Extra dimensions like these could create different worlds inside a multiverse. Although string theory is still a very theoretical and mathematically challenging area of physics, there is no pre-existing need to support its claims. The concept of superposition implies that particles can simultaneously be in more than one state until they are noticed. A parallel universe is a theory that says each possible result of a quantum experiment is its world. Although this way of understanding quantum physics is controversial and not agreed upon by all, it suggests that there might be a multiverse with endless alternative worlds. Cosmogenic microwave background, or CMB radiation, is the faint glow released during the Big Bang. Extensive studies of the CMB have given us important information about the early universe and how it has changed over time. Despite not directly supporting the idea of other worlds, the CMB does support the idea of a universe that went through a time of rapid growth, which is in line with inflationary cosmology. According to the anthropic principle, the universe's rules and factors are perfectly balanced to allow life to survive. According to some supporters of the multiverse theory, the anthropic principle could explain why there are multiple worlds with different characteristics. Within this point of view, our world is just one of many that could exist and have good conditions for life. Furthermore, quantum physics presents the idea of vacuum fluctuations, meaning that particles and fields can appear and exit from space independently. According to some theories, these quantum shifts could lead to the creation of new worlds in the multiverse. Within quantum field theory, various vacuum states could also cause the creation of many worlds, each with its own unique qualities. During considerable links of separate particles, quantum interaction can happen where their traits become linked to the point where one particle's state affects another. Regarding some readings of quantum physics, entanglement can link various parts of the multiverse, essentially linking multiple worlds. These ideas are just guesses because they have yet to be directly observed, but they bring up some interesting possibilities about how reality is linked at the quantum level. Although there isn't much clear proof for the multiverse yet, some cosmic facts and oddities have been seen as possible signs that it exists. For instance, unusual patterns or inequalities in the cosmic microwave background have led some researchers to think that our universe might collide with other bubble universes in the multiverse. Another reason for these strange events are also possible, but these are very speculative and disputed ideas. Despite the lack of direct observational evidence, supporters of the multiverse hypothesis say that it offers a mathematically sound and theoretically beautiful way to answer fundamental questions in physics, such as how the universe's constants are fine-tuned and where it all began. The multiverse theory, which says there are many worlds with different characteristics, might have answers to some of the most difficult problems in astronomy and particle physics. The universe may or may not exist, but people are working on creating experiments and ways to observe that it could provide proof of its presence. Scientists are looking into finding signs of crashes between bubble universes in the cosmic microwave background, or looking for signs of other universes and how matter and energy are distributed in our own. Researchers always try to discover more about the world and expand our universe's knowledge. Philosophers have many profound questions about the nature of reality, alternative worlds, and limits of what we can know. Philosophy and religion experts have argued about what the multiverse theory means for ideas like free will, cause, and the idea that the world has a higher purpose or meaning. Exploring these logical consequences gives conversations about the multiverse and its possible presence more depth and complexity. Black hole research and studying how they behave has led to theoretical breakthroughs that may affect the multiverse theory. For instance, the black hole information conundrum is caused by the clash between quantum physics and general relativity. Several theories, including the holographic principle and the idea of black hole complementarity, explain this problem by stating that there may be more than one universe and that information that goes into black holes may be stored or recorded in those other worlds. According to inflationary cosmology, the universe proliferated right after the Big Bang. In a universe with endless inflation, these inflationary processes could go on forever, creating infinite pocket worlds within a bigger multiverse. The endless inflation situation introduces a way to create many worlds, but also raises questions about time, cause and effect, and the start of the universe. Concepts of the multiverse are similar to computer science and virtual reality ideas. Within models and virtual worlds, it is possible to create and explore many different universes, each with its own rules and boundaries. While some support that multiverse theory and say that our universe might be like a game or virtual reality made by a more advanced society, the multiverse could be considered a massive collection of these models or alternate worlds. Despite continued attempts to test the multiverse theory, direct proof is complex and has many limits. Our current discovery methods can't reach many parts of the multiverse like other bubble worlds or alternative realities. Furthermore, some readings of quantum physics and theoretical frameworks like string theory are still guesses and have yet to be proven by evidence. The multiverse is studied using ideas from many fields such as astronomy, philosophy, computer science, and physics. Multidisciplinary discussion and teamwork are essential for learning more about the multiverse theory and what it means for how we understand reality. Researchers can use a variety of methods and points of view to find new links and understandings about the world and our place in it. The multiverse is an exciting and complex subject involving many fields of study. The multiverse theory is still being studied by scientists, thinkers, and the public, even though there needs to be more robust and consistent proof for its presence. It continues to spark interest, argument, and discussion. Within physics theories like string theory, inflationary astronomy, and psychological studies into the nature of reality and existence, the multiverse hypothesis raises essential questions about the world and our place in it. There will always be a fascinating and long-lasting interest in the multiverse as long as scientists keep working together across disciplines and coming up with new ways to do things to learn more about the universe.